Let us try to solve few problems related to the same segment. So I am considering one such problem. Say obtain the power series solution of y double dash plus 3xy dash plus 3y that is equal to 0 about the point x equal to 0. That means about origin we need to consider. So here what we have to do, given differential equation y double dash, or you can say d2y dx2, you can write this one also, d2y dx2 3x dy dx plus 3y that is equal to 0. Now comparing 1 with the standard form, d2y dx2 plus px dy dx plus qxy that is equal to 0, we get px, this portion is equivalent to 3x, and qx is equal to 3. Now obviously if you put x equal to 0 in place of px and qx, you can see both of them are well defined. So that means both px and qx are analytic at x equal to 0. So let the power series solution of 1 be y is equals to summation n equals to 0 to infinity a n x to the power n. You can also write summation c n x to the power n, that is same thing. So say this is equation number 2. Now remember, in my last class I told you need to find out first order derivative because dy dx is present in this expression as well as d2y dx2. That means you need to find out second order derivative too. So differentiating two with respect to x twice in succession means after first order derivative, first time if you take differentiation you will get y dash, and after that you will get y double dash. You will get y dash will be summation n a n x to the power n minus 1, but don't forget summation will be changed. Summation will be summation n equals to 1 to infinity, and then y double dash summation n equals to 2 to infinity. Again just differentiate this expression n into n minus 1 a n x to the power n minus 2. So you can consider these two equation as equation number 3. I hope you can see all these equations clearly, and my voice is also clear for all of you, I hope so. Now we need to consider these equations, or better to say expressions, of y, y dash and y double dash in the main equation, that is in equation number 1. So using 2 and 3 in 1 we get, first expression is what, d2y dx2, that means y double dash. So put this expression, so summation n equals to 2 to infinity n minus 1 a n x to the power n minus 2. then 3x dy dx, that means 3xy dash. So 3x summation n equals to 1 to infinity n x to the power n minus 1. After that you have plus 3y, that means 3 into summation n equals to 0 to infinity, and then you have what? Then you will see an x to the power n. So right hand side is equal to 0, so we are writing that too. Now we need to modify this summation. N equals to 0, n equals to 1, n equals to 2. Try to convert this summation in such a way so that you will get n equals to 0 to infinity. That means you have to modify this summation. So if you observe carefully, if I replace n by n plus 2, I repeat, if I replace n by n plus 2, then what will happen? N plus 2 is equals to 2. You can think in this way. N plus 2 equals to 2 means what? N will be 0. So in that case n will be 0 to infinity. That means in order to modify this summation as n equals to 0 to infinity, you need to consider that n should be right now changed into n plus 2. So here we are doing so. N has to be replaced by n plus 2. So n is equals to n plus 2. N plus 2 minus 1. That means it will be n plus 1. Then n plus 2. Then x to the power n minus 2. X to the power n minus 2 will give you x to the power n, and summation will be n equals to 0 to infinity. Why? Because n plus 2 equals to 2, so automatically it will be n equals to 0 to infinity. After that you have 3x. Now one more thing, here you can see you can have an additional line just before this expression. You can write this one too, n equals to 2 to infinity, n into n minus 1, an x to the power n minus 2, and after that you can write in this fashion, summation n equals to 1 to infinity 3n an x to the power n, because already there is some x, and then this part can also be written as what? Summation n equals to 0 to infinity 3an x to the power n, this is equal to 0. Now you can modify this one too. Now n equals to 1 to infinity, so n should be replaced by what? Obviously you can understand, if we replace n by n plus 1, then n plus 1 should be equal to 1. That means n will be 0 to infinity. That means if you express, or if you replace, better to say, n by n plus 1 in this expression, then actually what will happen? Summation 3 into n plus 1. After that you can write, or you can see actually you can also consider another step. No need to consider these two steps simultaneously, because powers are already same, n x to the power n, etc., etc. So I repeat these two steps again. Initially we are putting equation number 2 and 3. Again I will say, I will express these two equations in this following manner. First I will take y is equals to summation an x to the power n, y dash will be summation n an x to the power n minus 1, y double dash will be like this. From where we have obtained these two expressions, y dash and y double dash? Because simply we are differentiating this equation 2 from this particular portion. After taking the first order derivative, we will be able to get y dash. And also there is another important thing, summation has been changed, n equals to 0 to infinity, but here the scenario is totally changed. It should be n equals to 1 to infinity. Why? You can see my previous video, you will be able to understand why I have written n equals to 1 to infinity. Y double dash, again another term will be lapsed, and that's why n into n minus 1 an x to the power n minus 2, and summation should start from 2 to infinity. So here y equals to this, y dash equals to this, y double dash equals to this. All these three values should be used in the main equation, that is d2y dx2 plus 3x dy dx plus 3y equal to 0. So let me omit this line initially because it is little bit clumsy now. So to make a proper view, let me show this step again. Initially I have replaced these values, equation 2 and 3, in this equation 1, and consequently I have obtained this line d2y dx2, that is y double dash. So I have used this expression. 3x summation dy dx, expression of dy dx is what? Summation n equals to 1 to infinity n a n x to the power n minus 1. After that 3y is assumed to be summation a n x to the power n. So I have used all these expressions here. Now first you can modify this summation as well as powers of x. So first let us adjust the powers of x. How to adjust the powers of x? It's very simple. Here you can see no modification is required in terms of this particular term. Why? Because there is no additional term in front of this expression. So keep this one intact. Let me show you step by step. So initially I am writing this step, then I will write the previous step again what I have omitted. Then you will see summation n equals to 1 to infinity, then 3 n a n x to the power n, then summation n equals to 0 to infinity 3 a n x to the power n. Okay, so first identify where you have obtained x to the power n. If you have obtained x to the power n, then keep those terms intact. For example, here you have obtained x to the power n, here you have obtained x to the power n. But in the first case, we don't have x to the power n, we have x to the power n minus 2. So we need to modify this term. If you want to modify this term, what type of modification you want? You have to modify this term in such a way so that the power of x will become x to the power n. That means previously what was n minus 2 in terms of power, right now it will be equivalent to n. That means whatever was n, it should be right now n plus 2, as if you are adding this 2 with the previous quantity and with the new quantity. That means n minus 2 plus 2 will be n and n plus 2. This will be your new modified structure. So whenever you can obtain n, just replace it by n plus 2 to modify this expression in terms of some power of n, x to the power n. So what will happen? This part n will be n plus 2. This part will be n plus 2 minus 1. So it will be n plus 1 a n plus 2 x to the power n. And what about summation? N plus 2 should be equal to 2. Think in this way. Then n will be 0 to infinity. And no need to change this term because already you have obtained x to the power n for each of these expressions. I hope this thing is clear to all of you. So I am writing this one in this fashion. Okay, now look at the summation. If you observe the summation, you can see this part is n equals to 0 to infinity, this part is n equals to 1 to infinity, this part is n equal to 0 to infinity. Okay, so first you need to consider another modification related to the summation. Okay, so which one is the least possible summation? Least possible summation means this part starts from 0 to infinity. For the sake of definiteness, forget about infinity. I am saying you are talking about 0 to 5. So how many terms are there? 0th term, 1st term, 2nd term, 3rd term, 4th term, 5th term. If you count, you will get 6 terms. 1 to 5 will be what? As if in place of infinity, I am trying to say, imagine the same thing by considering n equals to 0 to 5, n equals to 1 to 5. n equals to 1 to 5 means what? You have omitted the 0th term. That's why 1st term, 2nd term, 3rd term, 4th term, 5th term will only appear. So definitely if you compare this to summation, here 0th term is absent. So definitely it is the smaller one. This summation is smaller in comparison to the previous one because at least one term is missing. And so you can say n equals to 1 to infinity. This is the smallest possible structure, and so every other possible summation present in the equation should be modified in terms of n equals to 1 to infinity. Always identify which summation is the smallest possible structure and change or modify the other summation accordingly. So first, putting n equals to 0, you will get 2 into 1, that is 2, a2, x to the power 0 is what? 1, then no need to modify the other possible structures. Remaining terms can be written combinedly as n equals to 1 to infinity n plus 2 n plus 1 an plus 2 x to the power n. But here we need not to do anything because n equals to 1 to infinity is the least possible summation. So keep this one intact. N equals to 1 to infinity 3n an x to the power n. And here you need modification again. Why? N equals to 0 to infinity is there. So putting n equals to 0, 3a naught x to the power 0 means what? 1 plus summation n equals to 1 to infinity 3an x to the power n. This part should be equal to 0. So everything has now modified in the following pattern. Summation n equals to 1 to infinity plus something. So identify the constant term. 2a2 is the constant term, and here another constant term is what? 3a naught. Okay, so first let us separate these two. All other possible terms can be put under one single summation, that is summation n equals to 1 to infinity. So let us separate these constant terms, 2a2 and 3a naught. 3a naught plus 2a2 and summation n equals to 1 to infinity n plus 1 n plus 2 an plus 2 n plus 1 n plus 2 an plus 2. After that an and after that 3an. So 3nan and finally you have 3an. So plus 3nan plus 3an within bracket then x to the power n. So finally we have obtained this type of structure. Again this can be simplified little bit. 3a naught plus 2a2 summation n equals to 1 to infinity n plus 1 n plus 2 an plus 2. This part will be written as 3n plus 1 an into x to the power n, that is equal to 0. So this is most probably equation number 4. As I told you in the previous class also, this is nothing but a mathematical identity. So if this is a mathematical identity, so what can you say? You can say which represents an identity. So this is the constant term. Right hand side constant term is what? 0. So 3a naught plus 2a2 should be equal to 0. Remember a naught and a1, these two constants should be preserved, and all other possible constants I told you in my previous class should be expressed in terms of a naught or a1 or in their combined form. So a2, 2a2 should be minus 3a naught. So 3 by 2 a naught. And now this expression is also 0. N plus 1 n plus 2 an plus 2 3n plus 1 an, this part should be 0. From where you have seen the summation will start, n equals to 1 to infinity. So we must write n greater or equal 1, because at least n should be equal to 1 for this relation, and you can choose any higher value of n also. So from here what you need to do, you need to find out the largest possible suffix. N plus 2 an, largest suffix is n plus 2. So let us try to find out the value of an plus 2. Automatically you will see we will have this type of expression. If we have this type of expression, then n plus 1 will be cancelled. 3 by n plus 2 into n, and this is true for all n greater or equal 1. And you can understand this relation is nothing but what? Recurrence relation for all n greater or equal this, which is the recurrence relation. So next we need to find out all other possible constants by putting n equals to 1, 2, 3, 4 in this relation. So say this is relation number or equation number 5. So putting n equals to 1, 2, 3, 4, 5, etc. in equation 5, we get, first putting n equals to 1, a3, right hand side will give you 3a1 by what? 3, that means minus a1. So a3 has been expressed in terms of a1, no need to modify. a4, putting n equals to 2, minus 3a2 n plus 2, that means minus 3 by 4. What is the value of a2? Minus 3 by 2 a naught. So that means 3 3s are 9, 4 2s are 8, 9 by 8 a naught. Then a5, putting n equals to 3, minus 3a3, 3 plus 2, minus 3 by 5. Here you will get a3. a3 is already obtained as minus a1. So 3a1 by 5. Then we can use one more thing, a6, putting n equals to 4, minus 3a4, 4 plus 2, putting n equals to 4 in this expression 2, minus 3 by 6a4. a4 right now we have obtained this thing, minus 3 by 6, 9 by 8 into a naught. Okay, so ultimately we will get what? 3 2s are 6, that means minus 9 by 16 a naught. In this way we can carry on. You can find a7 also, putting n equals to 5, minus 3a5, 5 by 2, minus 3 by 7 a5. a5 is what? Minus 3a1 by 5, so 3 by 7. a5 is 3a1 by 5, that means minus 9a1 by 35. So you can continue in this fashion, so I am writing etc. Okay, so now it's time to utilize all these values. Remember, we have taken to be the series solution of this main problem, that is y equals to summation n equals to 0 to infinity a n x to the power n. So from 2 we get the required power series solution as y is equals to a naught plus a1x, a2x square, a3x cube, a4x to the power 4, a5x to the power 5, and so on. That is why a naught, you need not to modify anything related to a naught. What is a1? a1x, keep this one intact because these two constants are trivially fixed. a2 is minus 3 by 2 a naught. So minus 3 by 2 a naught x square. What is a3? Minus a1. What is a4? 9 by 8 a naught. What is a5? 3a1 by 5. x5 and so on. Then a6 is what? 9 by 16. I hope you can remember. A6 is minus 9 by 16 a naught. A naught x to the power 6. Then a7 will be minus 9a1 by 35. A7 is minus 9a1 by 35. x7 plus dot dot dot. So let us separate as something into a naught plus something into a1. A naught 1, then minus 3 by 2 x square, then 9 by 8 x to the power 4, then a naught minus 9 by 16, or you can put minus sign. Then a1, first part is x, then a1 minus x cube, then a1 3 by 5 x to the power 5, then minus, because already you can see minus, so dot dot dot. Okay, so this is the required expression for y, where a naught and a1 are two arbitrary constants. So this is the required solution. So in this way we can solve this one. Now let us solve another problem. Suppose we want to find out the solution of this one. Always remember, before going through the solution, you need to check whether the given point about which you want to find out the power series solution, whether it's an ordinary point or it's a singular point. So I am writing the question: find the power series solution of the initial value problem. IVP stands for initial value problem. d2y dx2 plus x dy dx plus 2y, this is equal to 0, with y of 0 equals to 1 and y dash 0, that is equal to 0. Y of 0 equals to 1 means what? At x equal to 0, value of y is 1, and first order derivative of y, that is also 0 whenever x is equal to 0. So these two conditions will be utilized later on to find out these two arbitrary constants a1 and a0. Okay. So given equation, here nothing is mentioned, so you have to check about x equal to 0. Okay, so given equation is like this. Comparing it with the standard form, d2y dx2 plus px, this qxy, that is equal to 0, we get px is x, qx is 2, 2y, that's why qx is 2. Now you can easily understand, if you put x equal to 0, it has nothing to do with px and qx. Clearly both px and qx are analytic at x equal to 0. So x equal to 0 is an ordinary point. So about x equal to 0, let the solution be what? the solution be taken as y is equals to summation a n x to the power n, just like the previous problem, because till now we are talking about only ordinary points, that's why. Then what we need to do, we need to differentiate this relation twice. So this is the equation 1. Differentiating 1 twice in succession with respect to x, we get, I hope all of you can understand, summation y dash should be summation n a n x to the power n minus 1. N varies from 1 to infinity, because 0th term a naught will be vanished, and y double dash will be summation n equals to 2 to infinity n into n minus 1 a n x to the power n minus 2. This is the equation number 2. I hope up to this clear. Now once we have obtained the value of y, y dash and y double dash, so we need to put these expressions in the main equation. Main equation means whatever is given to us, that is in this original expression. So you can write using 1 and 2 in the given equation. What was the equation? d2i dx2, that means y double dash. So this expression should be used. Summation n equals to 2 to infinity. After that, n into n minus 1 a n x to the power n minus 2. This is the expression for y double dash. After that, second term is x dy dx. X dy dx means y dash is this one multiplied by x, then plus x n a n x to the power n minus 1 n equals to 1 to infinity, plus 2y, qx is 2, y is what? Y should be summation a n x to the power n. So 2, this expression should be equal to 0. Now first term, there is no multiplier in front of this expression, so we need not to change anything right now. X has to be multiplied, so n equals to 1 to infinity n a n x to the power n, then summation 2 a n x to the power n, this is equal to 0. Now x to the power n, x to the power n, so no modification will be required, but here you can see x to the power n minus 2, so you need certain modification. How to modify this expression? As usual, convert this thing into x to the power n. How to justify? That means n minus 2 will be modified as x to the power n. X to the power n minus 2 will be taken as x to the power n right now. So n minus 2 is equivalent to n. Think in this way. So n should be replaced by n plus 2. So if you replace n by n plus 2, n plus 2, n plus 1, a n plus 2, x to the power n. N plus 2, n plus 2 equals to 2 means n equals to 0 to infinity. N equals to 1 to infinity, then summation n equals to 0 to infinity to a n x to the power n, that is equal to 0. Now next task is what? Identify the least possible summation. N equals to 0 to infinity, n equals to 1 to infinity, n equals to 0 to infinity. Which one is least? Definitely n equals to 1 to infinity is the smallest summation. So convert the other summation into something plus n equals to 1 to infinity. So putting n equals to 0, 2 into 1, that is 2, a2 plus 1 to infinity, this expression. this part no need to change. Then putting n equals to 0, 2an x to the power n. So this is the final expression. So separate the constant terms, 2a0, 2a0, 2a0 and 2a2. So 2a0 plus a2 I should write. Then summation n equals to 1 to infinity. This part will give you what? N plus 1, n plus 2, an plus 2, then n a n, then n plus 2 a n, that is multiplied by x to the power n. So say this is equation number 3, I guess. 1, 2, 3. So that means this which is an identity, mathematical identity. So which is an identity. Okay, one more thing, those who know about the radius of convergence of any power series from the concept of real analysis, you can also say for some radius of convergence r, that the given structure is valid within some interval of convergence minus r comma r. But because we don't know, most probably all of us, what is radius of convergence right now, especially second semester students or third semester students, I guess, so that's why I am not using that term. So simply instead of that you can write this equation is an identity, so you can make it equal to 0. Every part can be considered equal to 0 because right hand side is equal to 0. So we can say, so coefficient of each term, so coefficient of each term in the left hand side, in the LHS of 3 must be 0, and thus we get this part equals to 0, a0 plus a2 equal to 0, that is a0 plus a2, that is equal to 0, that is a2 should be minus a0. Then we have this portion, n plus 1, n plus 2, an plus 2, n plus 2, an. This relation will help you to identify what is the recurrence relation. So n plus 1, n plus 2, an plus 2, that is minus n plus 2, an, this one you can cancel out. Okay, one more thing, summation starts from n equals to 1 to infinity, so you must write for all n greater or equal n. N plus 2 will be cancelled for all n greater or equal 1. So you have obtained this relation. This is say equation 4 and this is say equation 5, which is your required recurrence relation, which is the recurrence relation. So putting n equals to 1, 2, 3, 4, 5 and so on in equation 5, we get a3. If you put n equals to 1, a3 will be what? Half of a1, n plus 1, that is 1 plus 1, 2, half of a1. N equals to 2, after putting n equals to 2, a4, that is minus 1/3 of a2. So minus 1 by 3 a2 is what? Minus a naught. That means it will be 1/3 of a naught. Putting n equals to 3, a5 minus a3 by 4. a3 is already obtained as minus half of a1. Sorry, it should be okay, minus a3 by 4. So it should be minus minus plus, that means minus 1 by 4 into minus half into a1, that means 1 by 8 of a1. Then putting n equals to 4, a6 will be minus a4 by 5. That means minus 1 by 5. What is the value of a4? 1 by 3 of a naught. Then putting a5, n equals to 5, you will get a7. That means minus a5 by 6. a5 is what? 1 by 8 of a1. a5 1 by 8 of a1. And so on. So using all these values in equation 1, we get y is actually what? A naught plus a1x plus a2x square, a3x cube, a4x to the power 4, a5x to the power 5, a6x to the power 6, and so on. So y should be a naught. a2 is what? a2 is minus a naught. So minus a naught x square. a3 is half of a1, minus half of a1, x cube. a4 is 1 by 3 a naught, x to the power 4. a5 is 1 by 8 a1, x to the power 5. Then a6 is 1 by 15 a naught, x to the power 6. Then 1 by 48 a1, x to the power 7, and so on. So y a naught 1 minus x square, then x to the power 4 by 3, then plus a1 x minus x cube by 3, sorry, x cube by 2, I guess, x cube by 2, then x to the power 5 by 8, x to the power 5 by 8, x to the power 5 by 8, and then minus, we have minus, and so on. So this represents the general solution. Which is the general power series solution of the given equation, where a naught and a1 are two arbitrary constants. Now remember, y not equal to 0 and y dash not equals to y0 equals to 1, sorry, and y dash 0 equal to 0. So I can say, given y0 equals to 1, y dash 0 equals to 0, With the help of these two conditions, now we have to find out the expression for y. So this is equation number 6. This is the equation number 5 and this is equation number 6. From 6, y of 0 equals to 1. That means from 6, if you put x equal to 0, then y should be 1. So y, in place of y I have used 1. On the right hand side, a naught. 1 minus 0 plus 0 plus dot 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 plus a1, 0 minus 0 plus 0, because you are putting x equal to 0, so everything is 0. So ultimately you can say a naught is 1. Okay. Also y dash x from 6, what will be the value? A naught is constant, this is 0, this is minus 2x, 4 by 3 x cube and so on, then plus a1, 1 minus 3x square by 2, then 4, 5 x to the power 4 by 8 minus and so on. So y dash 0 equal to 0 implies this part is 0. Putting x equal to 0, we have minus 0 plus 0 plus a1, then 1 minus 0 plus 0, etc. That means a1 is also 0. And that means if you have used these two conditions, ultimate conclusion is what? y0 equal to 1 and y dash 0 equal to 0 will imply a0 or a naught is equal to 1, but a1 should be equal to 0. So from 6, the required power series solution is, already a naught is 1, so the result is 1 minus x square plus x to the power 4 by 3 plus dot dot dot. This will be your final structure. Hence the result. So in this way we can find out the specified solution also. So I think I have discussed all possible techniques how to about the solution of the power series solution of ordinary points. That means we have discussed about whenever we want to find out the general solution as well as we want to find out the specified solution, just like here what we have done. So I think this method is quite obvious for all of you right now. It is clear, it should be clear. And still, if you have any doubt, you can ask me your question. And in our next class, we will discuss about Frobenius method. That is the method by means of which we will solve the power series expansion, or we will deal with the singular points. We will have to deal with the singular points. So I guess this video will be useful for all of you. And if you have any question, again I will say you can ask me. So thanks for watching. I am closing this video. This live streaming is getting off now.